righty. So we talked a little bit about disk space. We talked about the problems with core files, the problems with slash filling up. Okay. The first thing that happens is file system is full. What do I do about it? Never look for big files. Wait a minute. It says that's what you do. Look for the big files. I had a guy call when I was in the response center. He says, I got a problem. Yeah, I can't reboot. What happened? Well, I went to my manager. Slash was filling up, and I said, I need more disk space. And he says, why? And he says, because it's almost full. And he says, let me add it. I've had some information about Unix. Find slash, look for a very large file, like more than 10 megabytes. Okay? And he found a couple of files. It says slash stan slash VM Unix. Hey, I can take care of that. rm slash stan slash VM Unix. Removed them all. Good. That's why I'm a manager. I was able to do that. And the system ran fine for several days until they decided to reboot. And they couldn't reboot because they removed the only two kernel files that existed for the system. They're gone. Now, you don't need them while you're running, but once they're gone, you've got to have them when you boot up. They had to go back and ignite the system because they had no way. See, if you can't boot the system up, your backup on tar, CPIO, fbackup, data protector doesn't do you any good because guess what those programs need? A kernel. They got to have a kernel to run. You can't restore those files unless you can boot up. So don't look for the big files. Look for the big directories. And the reason is that someone could be just messing around with recursion, and they created a bunch of 1K files. And in the slash directory or in the slash temp directory or someplace, they created 5 billion 1K files. Okay? There is not a big file anywhere in there. But I still have several gigabytes of space in one directory, and I don't know about that. All I know is the file system is full. I need to find it. So your friend is du minus kx. Minus k because we got to specify things in kilobytes, not half a kilobyte, also known as a sector or a block in Unix. So we're going to do kilobytes. X, don't cross over a mount point. Remember, slash contains slash plus all the mount point names, slash op, slash var, slash temp. So we want to stop if we get to slash temp. We want to stop if we get to slash var. Okay, so look just at that. Now we want to sort it and look at the first top things. So let's take a look and see what that looks like on a typical system. This is a N4000. So I'm going to do a du minus kx. And let's do our slash here and just see what it looks like. So this is kind of typical. Not useful because everything is kind of jumbled because it's in the order in which it found it in the directory. So we can't really find out whether we got large stuff. So the first thing we want to do is to sort it. So we'll take that and pipe it to sort. Whoops, sort, okay. And there we go, all sorted. No, well, let's see, what's happened here? It looks like all the 8s are together, all the 7s are together, all the 6s are together, but it's not numerically meaningful because it's an ASCII sort. We didn't tell it these are numbers, we just said sort left to right, and 6, and then comes 7, and then comes 8. 6 space is less in value than 6, 6. And so 6 space comes, and then 6, 6, and then 6, 6, 6, and so on. So that's what. So we got to tell it that that's what we have. Okay. So we'll now sort that, and I'm going to sort it in reverse order so that the big stuff is at the top and the little stuff's at the bottom. So there's our sort, and we'll go to the top of the list here. We'll get there. We'll get there. There we go. Got some real numbers. We'll leave out the minus r next time, and then we'll put the big stuff at the bottom. There we go. So this is normal, okay? This is the total size, 300 megs of slash. That's how big it is, okay? And that's occupied space. Underneath that, the biggest directory in there is etc, okay? Underneath etc, the biggest directory inside etc is vx. Underneath that is sbin. So between these two top-level directories, etc and sbin, 110 plus 205, that's almost 90% of all the storage in those two directories. Exactly correct as it should be, okay? If instead I saw something out there that said slash junk, and it was 300 megs in size, I know there's something really wrong. There's something way too big that doesn't belong there. Only Etsy and S-bin belong in root. Okay? Even if I get down here, I don't even think I have slash root in this one. No, I don't. Sometimes I have slash root. It's got a few megs of stuff at various times, and it might pop up. But these are the normal kinds of numbers that you expect to see. Okay? If you see anything that is out of the ordinary, you go fix that rather than look for the big files. You'll probably find thousands of small files. You might find a big file in there, but look for the space that's occupied first. So this one happens to be for an integrity system. And we see here 300 megs, the two biggest directories, just like it is on PA RISC, are bin and Etsy. Here's the same thing on a PA RISC machine. A little bit different size. I think this one is probably, this is 1111. The one I showed you before, the live system, was 1123. 130 megs used, 87 here, 63 there. A lot smaller, but then that's a smaller system. It doesn't have nearly as much stuff as the other one. So what fills up slash? Okay, first one is dev. Dev has absolutely zero ordinary files. No ordinary files. So you first run this command, find slash dev, look for ordinary files, that's what the F is, and do an LL. You should have nothing. If you find anything, remove it. Doesn't belong there. Ordinary files cannot be in dev. The only thing that's allowed to be there are special files called device files. Okay. You may also have a very large file called OM, because you wrote down on a napkin how to back up the system. tar minus CVF and the long parameter slash dev slash RMT slash OM. And of course the system administrator says, you mean there's more than one O? Yeah, there's three of them. Okay, there's a lowercase, an uppercase, and there's actually a zero, which that's what I meant. But if I put a slash through it, you're going to say, now is he slashing zeros or is he slashing O's? I don't know. I've always wondered about that. The rule depends on who you're talking to, amateur radio operators or people from Europe, you know, so anyways. And what will happen is, tar is a very friendly command. When you run it and you do not have a file called OM, what does it do? It creates it for you. And I'll store all your files in there. So it fills up slash. Ooh, that's a bad thing. So this is very careful. This is also one of the reasons you want to use backup commands very carefully. In other words, script them. Write all the information into the script. That way you won't make a mistake. You might have some junk files. Look for core. Whenever you see a core file, don't RM it. File it first. F-I-L-E, wherever the core file is, slash core, slash var core, slash wherever it is, and you'll get this information. It tells you the name of the program and what killed it. Ooh, that's fairly useful. Then you can remove it. But do it in that order. If you remove it, you'll never know what it was, and it's going to come back again, and you're going to say, you know, if I remembered that name, I could have fixed the problem, and it wouldn't have come back again. Use the same technique. Slashes all of the locations, and then you'll have nothing but directories in the slash directory, as we showed before when we move roots home out of there. You need to collect information on a safe system. Each one of your systems, you need to collect this kind of information on a safe system. The reason you want it to be safe, you want it away from the system that you're going to be protecting. If I have to rebuild this computer, I need information about what has been out there in order to recover it. I may not need to ignite it, but I need to have information about VG display and LVM conf and BDF and so on. Now, I have BDF megs here. You probably haven't seen that. That's a script that's on your CD. It's a combination of BDF in the way that it was meant to be, I think. Everybody seems to like it. What it does is it guarantees that every line is unique. Everything is in megabytes. If you have a long mount point name, it will not split it. It just makes the listing wider. So everything always lines up. You have a nice little feature called -S, which will summarize things. It says here's the sum total of each one of these columns. Okay. You can select by volume group. You can select several volume groups at the same time, or you can say all volume groups except a list of volume groups, and so on. Lots of nice little features. So get a copy of that. Need to take a look at IOScan. If you haven't seen it before, -K is your friend. If you've ever done IOScan and you didn't use -K, you will say, my gosh, that thing is fast. Instantaneous. This is incredible. How did I not finish this one? Well, here's what it does. IOScan by itself, and we'll just do a -F. This is an N4000, and it's got maybe 5 or 6 IO cards. A while to come back. Same command, IO scan minus K and F. Instantaneously. Comes back immediately. The difference is minus K says go in the kernel and read the information from there. Now, what will happen is if you went and added a card when the kernel wasn't looking, then IOScan will miss that with minus K. It won't see it. Why are you adding cards with power on? Oh, well, because we have OLAR, online replacement capability. Well, okay, I understand. There's some corner cases with certain types of machines, not most of them. Certain types of machines have the ability for online card replacement and add-on and so on, hot spares, hot replacement. But for the most part, the minus K command is 100% reliable because it's what the kernel is working on right now. Okay? So it's going to tell you the information very, very quickly. Let's see, set boot, this is the command that allows you to set the primary and alternate paths as well as whether you want to auto boot or not. So if we get a copy of set boot, it's going to look something like this. And it's going to show us, whoops, let's go back to here. And it's going to show us the primary and alternate paths and whether it's on or off. Notice I have it set for off. Now these are lab machines, okay? I use these in multiple boots. For instance, this one I believe, yeah, this is an 11.0 system. This is 11.11, okay? So if I boot the alternate one, it comes up on 11.11, so it makes it kind of easy. The problem is when you reboot and you want to pick the disk, how long do you have to pick the disk? 10 seconds. That's it. And if you miss it, what do you have to do? Start all over again, let it go through the self-test. If you got lots of memory, it's going to take a while. So I tend to set that, when I'm doing maintenance work, I tend to set auto boot off so that it comes up and says, what do you want to do? And it'll sit there for an hour. It'll sit there for 2 days. And then you finally say, okay, I want to boot off of the primary, or I want to boot off secondary. Now, in a production environment, that may not be a good thing. You know, say everybody's gone home, it's Sunday morning, there's been a power fail, the system comes back up, goes up to the prompt and sits there. How come the system's still down? The power's back? Oh, that's right, I turned off the auto boot. Why'd you do that? Oh, okay, can't win. So just be aware that's one of the things you can do. Now, I like to store copies of these things for historical purposes in a separate directory. So on this special administrative server, it logs all the information about the other servers for record keeping. I'll create a directory that is essentially the year, month, and day. And I'll just store those files in there, and that's it. And I just keep on creating those directories as needed. And I use this particular method here where we have most significant to least significant numbering like this because it sorts. You will find them exactly in the right order all the time. When you collect information, there are two ways of doing it. One is called nickel. Works pretty darn good for everything up to 1123. Doesn't work so good for 1131 because there's a lot of new stuff there. It was written 15 years ago by a fellow in the German Response Center at HP. And what it does is it produces a file, well, actually a whole series of files, that is a web page. Starts out with name of the system.html. And that file then points to all the rest of the files. There's an index file out there that shows things like, here's what it shows. Looks like this. We'll zoom in a little bit so you can see it. Each one of these is actually a link. So here's the name of the system. And here are the things that we can take a look at. I'll click on this and it'll show me the contents of setboot. Click on here and it'll show me the contents of rc.log. In other words, it collects all that stuff, puts it in one giant big file, which you can then transfer over to a web page. Or simply take all these files and store them on your PC and then click on the index.html. When you click on index.html, it's going to find everything in that directory. So you can actually store it locally. So IOScan, tombstone information, disk info, all that really nice set of pieces of information. But it hasn't been maintained for several years. And so the tool of choice now is CFG to HTML. Very similar. I think it's a little more, it's not as fancy looking. I like the format of nickel, but this one allows you to get a lot more information because it has a lot more features that didn't exist when nickel was put together. So it's a much cleaner interface. You can get it from that location. You need to join their little group of people that allows you to look at it. It's a Yahoo group. And the reason is because they take input from every sysadmin and says, how would you do this? I need to add that. And so you sort of contribute to the growth and maintenance of nickel. But for that, you get the ability to do that. At SourceDirect, we actually stored the 2 copies of CFG to HTML. One copy is version 3 something, and version 3 is 10.xx through 11.00, and then the 4 version is 11.00 on. So I'd leave both versions out there, so if you have really old systems, you'll still have a CFG to HTML that works just fine on the older systems. All righty. Oh, and of course you need the address for SourceDirect's FTP site. Surprise, surprise, ftp.sourcedirect.com. I do have a mixture of uppercase and lowercase. That's all lowercase, by the way.